Chapter 10, Section 3, we transition to triangles. So triangles can be classified in different ways. One way they can be classified is by their side lengths. Triangles can also be classified by their angle measures. So this will be explained on the bottom part of this sheet. But basically, you just need to remember, one way we can talk about differences in triangles is by their side length. The other way we can talk about differences in triangles is their angle measures. So some other vocab words you need to know is the word congruent. Now, to the common man, which none of you are, congruent just means the same thing as equal. But one thing that'll be emphasized when you take geometry is that congruent is what we say when the measurement of two things is equal. So yes, when we're talking literal just numbers, we can say 3 equals 3. But when the side of a triangle is 3 meters and the side of a different part of that same triangle is 3 meters, we don't say they're equal because those sides are not numbers. Their measurements are equal, so we call the two sides congruent. Now, the way they mark congruent sides are with little tick marks. And that's what you see down here. So as we'll discuss in detail soon, like you see a tick mark on all 3, that means all 3 sides are congruent. There's a tick mark on just 2 here, so just these 2 sides are congruent. And we know that means this one is not of the same length as these 2. Congruent angles have the same measure. So that means their measure is equal, but the angles themselves are congruent. And congruent angles are indicated in a diagram with arcs. Oh man, there we go, arcs. So that's what you see right here. Like this is saying 3 congruent angles. So all 3 of these angles have the same measure. So first we're going to talk about how the angles can be classified by their angle measure. Okay, the first word is acute. It's an acute triangle if all angles are acute. But what does acute mean, you might ask? Well, it doesn't really mean that it is cute or pretty or handsome. The word acute means all the angles are less than 90 degrees. So I'm pretty sure you've learned this before, but just a reminder, a right angle is 90 degrees. So if all the angles are less than 90 degrees, it's called acute. It's called an obtuse triangle if there is one obtuse angle. And obtuse means greater than 90 degrees. So it's this angle right here. I'm not saying it's equal, I'm just trying to mark what I'm talking about. This angle right here is what makes this triangle obtuse. Now just so you know, this isn't something we'll do in great detail right now because you're in pre-algebra, but in geometry there'll be lots more detail about this. For it to be acute, all 3 have to be acute. For it to be obtuse, just one angle would be obtuse. It's actually impossible for a triangle to have more than one obtuse angle. So if there's just one obtuse angle, it's called an obtuse triangle. Now, this is called an equiangular triangle. Equa meaning equal, angular angles. Equiangular. And that's when it has 3 congruent sides. But there's one thing I want to make clear. An equiangular triangle is also an acute triangle. So it's almost like when you're talking about numbers, how we classify them differently. I think it was in the last section. So you can think about triangles this way. We've got all triangles, and we have over here, we have obtuse. Over here, which we haven't talked about yet, but that's the last one, is right. And then here is acute. But inside the acute group, there's another group called equiangular. So obtuse, acute, and right are three completely separate things. You cannot be more than one of those at a time. But acute angles might be equiangular or they might not. Because equiangular, you don't have to memorize this number, but it turns out every angle is exactly 60 degrees when it's equiangular. And 60 is obviously less than 90, so since all of those are equiangular, this is also acute. However, typically when they give you this and show that all three angles are equal or congruent, they'll want you to just say this, because this is more specific. So if you put acute on this, I'd probably give you partial credit, because that's true, but a better answer is to say it's equiangular. Then the last type is a right triangle. So one right angle. Just like there can only be one obtuse angle in a triangle, there can only be one right angle in a triangle. And that little box is the way they show you that it's a right angle, and right angles equal 90 degrees. So other than equiangular, which that its name hopefully tells you, it's because all the angles are equal. The other three are based on if you're less than 90 for all of them, greater than 90 for one of them, equal to 90 for one of them. Now we talk about the sides. First, equilateral. So equa means equal, lateral refers to the sides. So when all three sides are congruent, then it's also called equilateral. When two sides are congruent, but not the third. So you can't just say, oh, well, this would apply here because those two are congruent, because this one also is. This type is when only two and exactly two are congruent. Third one's not. This is a strange word. It's called isosceles. So that's ISOSCELES. And the last kind is also a fun word. So none of these sides are congruent. So that's when it's scalene. I'm sad to say, while I can explain what equilateral means in equiangular, I'm not exactly sure where the word isosceles comes from or scalene. I should talk to the ELA teachers about that. Maybe we can find out. So you do need to commit these words to memory and understand equilateral means three congruent sides. Isosceles means exactly two and only two congruent sides. Scalene means no congruent sides. So now that we have these 7 terms, we're going to actually practice identifying them. Now this says, find the missing angle measures for each triangle. We're going to do that second. I want to teach that after we deal with talking about, actually, I take that back. I think we should do that first, then we'll go back and classify them all. So the other fact you need to learn in this lesson is that if you add up all three angles, all three inside any triangle, it will always add up to 180 degrees. So every triangle, doesn't matter if it's acute, equiangular, obtuse, right, all of them add up to 180 degrees. So we can figure out this third angle by saying, okay, I know 60 degrees plus 60 degrees plus x degrees has to equal 180 degrees. Sixty plus 60 is 120. We subtract 120 from both sides, and we get that angle x is equal to 60 degrees. So the reason I realized on the spot was I need to teach that first is because we need to know that that's 60 degrees, because then we can easily see all the angles are equal. They're all 60 degrees. So we would call this equiangular, because all angles are equal. If you notice, there's a tick mark in all three of them, so that means all the sides are also equal. So I'd say it's equilateral. So that defines it by its angles. That defines it by its sides. And I'll tell you a little secret. This isn't true for any of the other words we'll use. But these two always go together. Always. If all the angles are equal, all the sides are equal. If all the sides are congruent, all the angles are congruent too. Okay, number 2. Let's find out that missing angle. We know if we add 65 degrees, that's that angle, plus 90 degrees, because all the right angles are 90 degrees. And the one we don't know, it should add up to 180 degrees. 65 plus 90 is 155. Then we subtract 155 from both sides. And we get that x is equal to 25 degrees. So this is 25 degrees. So first, let's think about its angles. Well, we have a right angle, so it is a right triangle. However, there are no tick marks here. There's nothing telling us any sides are equal. And when no sides are congruent to each other, we call it scalene. Okay, number 3, we know if we add 30 degrees plus 40 degrees plus x degrees equals 180 degrees. Now, you notice for whatever reason, I tend to put x as the last one. That isn't important. It doesn't matter what order you put these angles in. You can put 40 first, x first. You can put it in the middle or last. It doesn't matter. 30 plus 40 is 70 degrees. We subtract 70 from both sides, and we get x equals 110 degrees. 110, that's greater than 90. So that means that if I'm defining this based on its angle, I would have to say it's obtuse because we have one angle that's greater than 90 degrees. And there's no tick marks, so none of the sides are congruent. So just like this previous one, we'd have to say it's scalene. So one other thing that I want to emphasize is important as we do these, you've got to keep separate in your mind what words have to do with angles and what words have to do with sides, because it's asking you to do both, but you don't need to say obtuse and acute. Not only will that be wrong, those two can't go together, but those both have to do with angles. So you got to make sure you remember which words have to do with angles. That's acute, right, obtuse, and equiangular. Which ones have to do with sides? Equilateral, isosceles, and scalene. Okay, so I'm going to show you a trick that makes this a little bit faster as far as solving for the angle. If you notice, if we want to get x by itself, we could just subtract 40 to that side and subtract 30 to that side. So instead of setting it up as these all added together equal 180, I'm going to say 180 degrees minus 40, because we know that one, minus 70, because we know that one, is equal to the one that's missing. So if I'm just looking for a third angle, I just subtract the two I know from 180, and that'll give me the side. So minus 40 minus 70, that's 110. 180 minus 110 is 70 degrees. So x is 70 degrees. So as I look, I see that all the angles are less than 90. So it's acute. I also see there's two tick marks. So two sides are congruent. So that's isosceles. So this one is acute and isosceles. Number 5, I'm going to use the same trick. I'll do 180 minus the 90 I see here, minus the 45 I see here, to figure out my missing angle. Now this is pretty easy calculator work, so I'm just going to tell you that x is going to be equal to 45 degrees. So this does have a right angle, so that means it's a right triangle. And it has two tick marks, which means it has two congruent sides. That means it's isosceles. This is a right isosceles triangle. So notice, it could be right scalene, like number 2, or right isosceles, like it is in number 5. Okay, number 6, I'll do 180 minus 65 minus 40 degrees, and that will come out to making x 75 degrees. So as talking about angles, those are all less than 90. So this is an acute triangle because all the angles are less than 90 degrees. And there's no tick marks. So this can be scalene because none of the sides are congruent. So it's possible to be acute and isosceles. It's possible to be acute and scalene. Like I said, these two always go together. The rest can be mixed up. Okay, number 7, we do 180 minus 30 minus 30. That's going to tell us that x is equal to 120 degrees. So 120 is that one right there. So that is obtuse because we have an angle greater than 90. And I see 2 tick marks, so that tells me that it is isosceles because there are two sides that are congruent. So like I said, they can be all mixed up. This one's obtuse isosceles, while number 3 was obtuse and scalene. Okay, last one, 180 minus 90 minus 15 degrees. That will tell you that the missing angle is 75 degrees. So we do see a right angle here, so that means it's a right triangle. And there's no tick marks, so none of the sides are equal, so this is scalene. So this really showed about every possibility there is. I don't mean all the number possibilities, but as far as combining the terms, because we got right isosceles in number 5, we got right scalene in number 8. So make sure you make a point to memorize these terms and understand what they mean, because this is essential for understanding how to describe triangles. And remember that the 3 angles inside a triangle always add up to 180 degrees. The final kind of problem you'll have to work with in this triangle section has to do with ratios. Ratios compares how big each angle is compared to the others. And it's possible with triangles to express that relationship between the 3 sides and their lengths as a ratio. So if a triangle, sorry, I said sides, it's angles. You'd think I'd read the whole thing. Ha! So the ratios of the angles between each other can be expressed as a ratio. So a triangle that's equal angular, all the angles are equal at 60 degrees. The ratio would be 1 to 1 to 1, because it just says 1 is equal to itself. All the angles are equal. A 30, 60, 90 triangle would have a ratio of 1, 2, 3, because one angle, the smallest, is 30 degrees. That's the 1. The second angle is twice that big, and that's a dash, not a negative there, or a hyphen, dash, I think dash is it. 2 times 30 is 60. And then the third angle is 3 times as big as 30, so we do 3 times 30 and get 90. So the question is, those two are relatively simple, but how do we determine the angle measures when all they give us is the ratio? So let's work through it with the steps for this example right here. So the example says a triangle's angles have a ratio of 2, 7, and 9. So our first step is to add the 3 numbers together. So 2 plus 7 is 9, plus another 9 is 18. So adding those 3 numbers together gives us 18. Now we do 180 divided by that sum. So 180 divided by 18. And you can plug this in your calculator if needed, but it's equal to 10. So what that means is if there was a 1 here, like 1 up here in this example equaled 30. But what 1 equals in this example is 10. So just like up here, we said, well, the 1 is 30 degrees. So the 2 must mean double 30. The 3 must mean triple 30. So this is saying that the 2 must be 2 times 10, so it's 20 degrees. The 7 must be 7 times 10, which gives us 70 degrees. And the 9 must be 9 times 10, which is equal to 90 degrees. And you can confirm this works by adding these together and making sure it adds up to 180. 20 plus 70 is 90. 90 plus 90 is 180. So that means we did it correctly. So the triangle whose angle measures with a ratio of 279 has angles that are 20 degrees, 70 degrees, and 90 degrees.